Alright, this video is for quantitative data and distributions. Alright, so quantitative distributions. One type of quantitative distribution is the dot plot. This is a simple display that places dots along an axis for each case in the data. So, here's an example. Some of the pros to making a dot plot is that it's simple to make and it shows each individual data point. The cons would be that it can be very time consuming if you have a lot of data. Also, you have to count to get the exact total. So if they just give you the picture, you have to count each dot to figure out the sample size. Alright, 2. A stem plot or a stem and leaf plot is like a histogram, but it shows individual values. So we're going to make an example. So Babe Ruth's home run totals each season for the Yankees are below. So I'm going to make a stem and leaf plot. I'm going to have a line going down to separate the stems from the leaves. And then I would put a title. And I would have to make a key. So my stems are going to be the 50s, 40s, 30s, 20s, 10s. So those numbers. So 2 stands for 20s, 3 stands for 30s. Then I would put in all the leaves. So 20, I have a 25 and a 22. So I would put 2, then 5. Okay, you always want to put your leaves in order. So that's what my stem and leaf plot there would look like. My stems, these are my leaves. They need to be in order. And then no comma separating the leaves. Alright, my key, if I had 2 and then the line separating and another 2, that would mean that I had 22 home runs. Because this is talking about home runs. So now a back-to-back stem plot is when you have a stem plot with 2 different things, so you have 2 sides to it. Roger Maris' home run totals for the Yankees are as follows. Create a back-to-back stem plot with Babe Ruth's. So I'm going to copy over Babe Ruth's stem plot. That's what we have for Babe Ruth. I'm going to have to add some new stems. Okay, so I need something in the 10s and something in the 1s place, basically. So now I'm going to add my leaves to the other side. So I had 8, so that's going to go with the 0, 0, 8, 13, 14, and 16, 23 and 29, and then 61. So I got to have a table or a title, home run totals with the Yankees, and we have a key. So again, the same key. Babe Ruth on the right, Roger Maris on the left. And that's what a back-to-back stem plot would look like. This is really good if you're trying to compare 2 things side by side. Alright, splitting stems. When your data is clumped together within only a few stems, it's a good idea to split them up. So the stems can be split up by 5s, 2s, or 1s. Alright. Histograms. Alright, histograms are visually strong, and they're really good if you're going to determine the shape of the data. Some of the cons are that you cannot read the exact value because the data is chunked into groups. So we don't know what every single response was or every single piece of data. And also they're more difficult to compare 2 data sets. Okay, especially based on how you broke them up. If it's not the same, it's a little bit difficult to compare. Alright, histograms. So, you can find the histograms, the instructions on page 46 in your book. I'll make a separate video walking you through how to do all of this in the calculator. But if you put all this into your list and then you create a histogram, you can do that. Alright, 4 types of histograms. We have frequency, relative frequency histogram, cumulative frequency histogram, and cumulative relative frequency. So with frequencies, we're dealing with numbers. With relative frequencies, we're dealing with percentage. So same with the cumulative. Cumulative, it's just building each time. So you're taking the last column, kind of like when we had the segmented bar graph. You're taking the last column and you're including that and you're adding to it. Okay. Using sucks to describe data. So not because statistics sucks, but just an acronym. So S is for shape. The shape can be unimodal, bimodal, multimodal. Modal means the mode the most often. Uniform, it can be right skewed, left skewed, or symmetric. Unusual features is the U. Those can be outliers or gaps. C is for center. Your center will either be your mean, median, and quartile. So those are things you can use to describe the center. And then the spread, you could use the standard deviation, the range, or the interquartile range. Okay, and there's certain times when you would use one over the other. All right, measures of center. So we have the mean, which is the arithmetic average, and the formula is x bar equals the summation of x sub I over n. So we pronounce this x bar. The summation of x sub I is each individual piece of data, and then n is the total number of pieces. And then our median, you should remember, is the middle observation. So it must be in order from least to greatest, and then you find the middle number. If you have two middle numbers, you add them and divide by 2. Measures of spread. Standard deviation, range, and interquartile range are measures of spread. So standard deviation is a number that describes how much the data is spread. Okay, it's the average difference of each point from the mean. And then the higher the number, the more spread out the data is. The formula is S sub x equals the square root of 1 over n minus 1 times the summation of x sub I minus x bar quantity squared. The range is the difference between the lowest and the highest values in the data set. And the interquartile range is the difference between the first and the third quartiles, so Q3 minus Q1. Quartiles are the medians of the lower and upper half of the data. Q3 is your upper half, Q1 is your lower half, and then for standard deviation, we'll do a couple where we actually use the formula and we find the standard deviation like long ways, but only a couple times, and then I'll show you how to do that in your calculator. So we have a 5-number summary. 5-number summary includes the minimum, quartile 1, the median, quartile 3, and the maximum. All right, on your calculator, if you need to find the mean and the standard deviation, you go to stat, calc, one variable stats, and again in the other video I'll show you how to find those things with the calculator. All right, variance is the standard deviation squared, or the standard deviation is the square root of the variance. So 2 examples. If the variance is 16, then the standard deviation. If I know the variance and I want to find the standard deviation, I can take the square root of the variance, I get 4. If the standard deviation is 6, find the variance. Well, if I know the standard deviation, I want the variance, I'll just square the standard deviation, and I get 36. All right, box plots. Box plots are a graphical display of that 5-number summary. So we have the minimum, quartile 1, the median, quartile 3, and the maximum. And then our outliers, we have the 1.5 times the interquartile range. That's our rule for finding the outliers. So our lower fence, the fence like where you draw the line, anything that falls outside that fence is an outlier. The lower fence will be found by quartile 1 minus 1.5 times your interquartile range. Q3, or your upper fence is Q3 plus 1.5 times your interquartile range. A modified box plot is just a box plot that shows you the outliers. So the whisker goes to the point, whatever is the furthest point before there's any outliers. All right, and your calculator, you can put it on modified box plot. Parallel box plots let you compare 2 or more box plots at the same time on the same scale. All right, describing distribution, so describing their shape, center, and spread. So shape, we have unimodal, where it's only one mode, it only peaks up at one point. Bimodal has 2 modes, so 2 pieces that occur pretty often, so it has 2 major humps there. Uniform, it's pretty flat. Symmetric, it goes up evenly and then down evenly. All right, you could have left skewed, so the tail is to the left. Right skewed, where the tail is to the right. You can have outliers, so you have all this distribution, and then you have a couple random stragglers. And then you can have gaps. So if you have like noticeable gaps, then you want to definitely make sure you mention those when describing your data. You could have it clustered all to one side and then nothing on the other side. or granulated, where it's kind of one and then a space. So those are consistent, understandable gaps. All right, and in the center, we use the median when comparing skewed distributions or distributions with outliers. And we use the mean when comparing symmetric or roughly symmetric distributions. The spread goes along with what measure you use for the center. So if you're using the mean, you're going to use the standard deviation and the range. If you're using the median, you're going to use the interquartile range and the range. Alright, so mean versus the median, I also included the mode. So if you have a symmetric distribution, so it's kind of that normal curve, the mean, median, and mode are all going to be right down there in the middle. Alright, if it's skewed, the mean is going to be pulled towards the tail. And on that first one, you have to draw that line there is missing. So if it's skewed left, the mean is pulled towards the tail, so the mean. Then you have the median, and then the mode is wherever the most is happening. So it's going to be right at the peak. All right, right skewed, the mean is pulled towards the skew, so it's pulled towards the tail, then median, and then mode.